Alright, this is part 2 of number systems. If you never watched part 1, please watch it because that's obviously that's basically everything you need to know to answer this. This is the application of number systems, and these will be the questions that's going to be asked in your class test. In fact, I can predict exactly what's going to come out of class test, and I'm telling you this is going to come out, and probably this, right? If you look at all the exam papers, there's only like this type of question that's going to come out, and this type. I'm not even joking. In number systems, the whole topic, so 3 marks, 4, 5, 6, 7, 8 marks you can get cashed in out of 50, that's 16%, right? I'm telling you, please learn this thing and learn this. If you know these two, I'm telling you they're gonna come out of the class test. Okay, maybe they won't come out, but it may come out in June or somewhere. Number system has to come out. These are like one of the two examinable concepts that can and is popular that can come out. Alright, so let d equals to 4n plus 1 such that n is an element of integer. If xy is elements of d, so show that x times y is elements of d. So as soon as I see this, I want to just close my books and go home. Okay, if that makes sense. But trust me, it took me about an hour to understand this whole line, but I finally understood it, and now it makes a lot of sense. Okay, so let d equal to that. So basically it's saying this, right? N is an element of an integer. So basically it says this, right? You put any integer in that, and then you get a result. That's basically what the pattern is, or the formula, right? For example, if I take, let's say 1, which is an integer, 4 times 1 plus 1, that is 5. So 5 will be the result of this whole thing, right? And then if I take 2, that's 9, okay? And then if I take 3, which is also integer, that is 12, that's 13. So these are the results of this whole thing over here, right? So that's how you work it out, right? Now they're saying this, right? Now this is not the question, I'm just showing you, right? But I'll just leave it there for now, we may need it. If xy is an element of d, so if x and y, those are random numbers, right? So if xy is an element of d, what does that mean is that xy will be like one of these numbers here, right? It will be like the final product of this formula, which is giving those numbers. So xy will be one of these numbers here. Show that x times y is an element of d. Okay, so basically you have to show that any number x, y times together will give you any of these numbers here. But trust me, this is something very, very routine. Okay, what I mean routine, there's only one formula, and there's only one formula you use, you get it 100% right. If you get this, use only this formula that I'm showing you, okay? Alright, so number 1. This is routine. When I say routine, this is what you have to do. There's no other way. Well, there are other ways, but this is the best way. It might not make sense, but it will make sense. Alright, show that x times y is an element of d. So x and y are two numbers, right? Basically they're saying when you combine them together, it must show that it's an element of d. So this is what I'm going to do, right? I'm going to put x in the equation, then I'm going to put y in the equation. Now what I mean is, instead of n, put x. So pretend that x is actually a number there, right? So that will be what? It'll be 4x plus 1, right? Because if x was a real number, like example 3, which is in an integer, you put 3 in, that's 12, that's 13, you know? So x is like, you're pretending like that's actually a number and it gives a result. So 4x plus 1, and then you put y, that is 4y, 4y plus 1, okay? Alright, so basically they're saying this now. Now you got these two numbers, but you can't really know what the numbers are because they're in x and y. But you have to show that x times y is, x times y is an element of d. So this is what you do, right? Multiply x and y together, right? This is x, that's y on the right. So multiply, and let's see where you end up, right? So you got x and y times it. So that is 4x, right? That's 16xy. So 16xy. Okay, I'll just pause this and I'll do the whole equation. Okay, so multiply this by that by that, and that by that, FOIL it, right? I got this. Now, what you must realize is when you come to this step, there's something very, very strange, right? Now, I'll just put a bracket over here, right? Just for fun. Well, not for fun, but just for fun. Now, can you see everything over here is like in multiples of 4? Okay? And somehow 4 is somehow they're related. And I got plus 1 over there and I got plus 1. So this is what you do, right? Take out 4 as a common factor from here and let's see where you're at, right? Let's see, because I'm seeing 4 is something. 4 is just picking my eye. 4, 8, 12, 16, that is 4xy. Okay? So 4xy. And then take out 4 from that, that's plus x. Then plus y, so plus x plus y, and then obviously put the brackets plus 1. So I did nothing wrong over here. I didn't break any algebra rules. Okay, I'll just put a bracket over there. There's no breaking rules. Plus 1. Now what I want you to do is this, right? 4 times something plus 1. 4 times n plus 1. So here's the thing, and here's the most satisfying part, right? 4xy, it's basically integers, right? All of this is integers, okay? Integers. So you basically prove that this xy is an element of D. Because any element, this is the formula to get 4n plus 1. So technically this is 4n plus 1. So if this is 4n plus 1, you show that x times y is an element of that, right? It will produce this. So you can say, now you can say 4x plus y is an element of integers. Therefore, x times y is an element of D. There we go, we proved it. Because check here. 4. Now I don't put it as your answer, but I'm just showing you. And this can be represented as n. Then obviously I got plus 1 at the end. Comes to the same formula. So it is an element. It's there. Because remember, element is what's inside. So by multiplying x and y, we got that. So one thing which you need to understand, this is routine. If you get this, is the only way to do it. So learn this. I told you, first of all, we need to put x and y in that formula. Okay. So we put x in the formula, we got this. We put y in that formula, we got that. Now let's multiply together and let's see if we come to something like that. We didn't multiply, then we say, hey, 4 is something wrong with 4 there. So we take out 4 is a common factor, we got that. And then we saw it's very, very common. Therefore, we can conclude, right? 3 marks, 1 mark here, 1 mark expanding, 1 mark. Basically saying x, y is the element of D and getting to the final answer. Okay, this is one way number system is tested. I'm telling you, you probably will get this, okay? If not something similar, they may not say x, y is an element of D. They may say zy, or they can give another equation. Instead of 4n plus 1, they say 4, let's say maybe n plus 1. So I'm telling you, they only past papers in university, they only change stuff. That's what I'm noticing. Now, okay, I can probably do this in the next couple of minutes. Okay, so next one. Okay, so 5 marks, 5 marks, 10%. Okay, I'm telling you, this you're probably going to get, and this is so easy marks now because it's routine. There's only one way to do it. Okay, suppose n is an integer, right? So n is an integer. We know what's an integer. Give a precise condition for n to be even. So that n we're only looking at. How can you put n in such a way that any number you put n will be even? So the first answer will be 2n. Because think about it very, very carefully, right? 2n will be the answer. Because 2 times any number will be an even number. For example, 2 times 1 will be 2. 2 times 2 will be 4. 2 times minus 1 will be minus 2. So 2n will produce any even number in the whole entire integer system. Okay? So that's my answer for the first one. Second one. If n is even, show that minus 1 to the power of n is equal to minus 1. So basically, ignore this is equals to 1. You basically need to prove some way that you'll come to 1. So straight away, if n is even, show that minus 1 to the power. Okay, so if n is even, so make n even. So minus 1, and we found, see, it gets the follow-up answer. So if n is even, so n has to be 2n, because 2n produces all even numbers in our system. So somehow to prove that this will come to 1. Aha. So you know in algebra you got that law which is like this. Now this is like the reverse of the law. Minus 1 to the power of 2 to the power of n. I can rewrite that as this. Because why? When raising a power to a power, you multiply. So minus 1 to the power of 2 times n, 2n. So this is exactly, you're just rewriting the form here. And then minus 1 to the power of minus 1, to the power of 2 minus 1 times minus 1 is 1. Okay? 1 to the power of n. So you got the whole thing to be 1 and then to the power of n. Now just 1 to the power of n is equal to 1. Because think about it. 1 to the power of any integer here, 5 is 1. 1 times 5 times 1 times 1 times 1 times is 1, 1, 1. So no matter what, this answer will be 1. So therefore, you showed that this is equal to 1. Done. Now, okay, you're going through this maths exam. Now, this one now, n is odd. Now, what are we going to do here now? I was so good in all this. Now, what's this? It's simple. If 2n you said was even, then what will be odd? It's 2n plus 1, right? Because think about it. If you get an even number by saying 2n, alright, if you just plus 1 to that even, you'll get to the next number which is odd. So it's 2n plus 1. So let's see. So minus 1. You can test it out. 2n plus 1. For example, let's put 2. So it's 2 times 2 is 4 plus 1 is 5, which makes it odd. So minus 1 and n now will be 2n plus 1. 2n plus 1, right? Now you are somehow sure it's equal to minus 1. So now you're confused. Now how to do this? Very, very simple, right? Algebra law. Minus 1 to the power of wait. Let's see. Wait, let me redraw that. Alright, so I just wrote it like this. Minus 1 to the power of 2n times minus 1 to the power of 1. Because when you're multiplying exponents together with the same base, you add them. See, so I'm just doing the reverse. Now, minus 1 to the power of 2n. We did this before where you put the 2 in there and put an n. So that's, okay, we can redo it. Minus 1 to the power of 2 times n. Minus 1 to the power of 2 times n is what? Minus 1 times, that's 1n, right? So 1n. And then obviously now we have to work at this. Minus 1 to the power of 1 is minus 1. So this times minus 1. Now here's an interesting part. 1n, it's 1, it has to be 1, okay? Because n is any integer. 1 to the power of 5, 1 to the power of 10 is like basically 1 times 1 times 1. It will always give you 1. So 1 times minus 1. Oh, come on, man. It's an interesting part now. This thing messes up. Okay, so 1 times minus 1. Okay, what's wrong over here? There's such, suspense now. Oh man, now doesn't keep. You know what now? So 1 times minus 1. Guess what? Yes, you guessed it. Is equals to minus 1. Bam, we got it. Minus 1. So you see, so when you want to prove something, get to the left, do the left, and come to the right answer. Okay. So as you can see, there are number systems. Yeah. So as I'm saying, they can only ask with this in number systems. Yeah? 3 marks, 3, 4, 5, 6 marks cashed in. And this video, I did yesterday, set the area. Check. You can even score those 2 sections. And now looking at this, this is questionable. I never learned that as yet, but yeah. So that's the number system. Make sure you know that it's routine, so there's only one way to do it. They just have to put different numbers, so that's all. The method is the same. So yeah, thank you. Subscribe, like, and yeah, enjoy your day.